Okay, solving equations. We're going to do linear, literal, absolute value, and quadratic equations. Equations, solve your own problems. But for real. Okay, so linear equations. You've been solving these for a long time. Should be pretty easy. So we're just going to, you have to get k to one side and everything else to the other side. So we distribute that in 64 plus 8k. And then combine like terms. So that's going to be 65 plus 8k. And then let's get all the k's to one side and get all the numbers to the other side. So I'm going to subtract 8k over, and I get, here, I'll just do this. So I'm going to subtract this 8k, and I get negative 13k, subtract 39, and that is something, 26. And then divide by negative 13, and we get k equals negative 2. Sweet. Let's just click through, make sure we got that. Cool. This one. So whenever you have a fraction like this, let's get rid of the fraction. The way we're going to do that is multiply by negative 7 to both sides. Because on the left side, those negative 7 cancels, and I'm just left with 4y minus 7. On the right, I have negative 7 plus 46y. Now again, let's get everything to one side. So I just subtracted the 42y and I get negative 38. Add the 7, I get 0. Well, if I divide by that, I'm still just going to get 0. So y equals 0. This one, we have a fraction in there. We have a negative, so we have to distribute both of those. So 4/3 times 9. Well, 9 divided by 3 is 3. Times 4 is 12, so that's going to be 12. 51 divided by 3 is 17, I think. I might have did that wrong. 51 divided by, yeah, and then times 4 is 68. And then we have 7w minus 68 plus 5w. Combine like terms, so we have 12w minus 68, 12w minus 68. Well, if we cancel everything, it's just going to be 0. So you're going to end up here. If we subtract 12w, I left with 0. If I add the 68, I'm also left with 0. So 0 equals 0 is true. So that's infinite solutions. So that means whatever we plug in, you're going to get a true statement. Now say that you did this, and we ended up with 12w minus 68 equals 12w plus 4. Okay, so if I subtract the 12w, those cancel. I'm left with negative 68 equals 4. That is not true, right? So that just means this is no solution. So if you end up with something, two numbers that do not equal each other, it's no solution. If you end up with two numbers that do equal each other, then it's infinite solutions. Okay? Okay, so no solution is when the lines are parallel, because linear, that means we're doing lines here. So no solutions mean they have the same slope, they're parallel, they're never going to cross. If it's one solution, that means they're different slopes and they just cross at one point, and the intersection is the solution. And if it's infinite solution, that means that they're the same line. So that means that every point on there is the same point on the other line. Okay? Now, solving literal equations. Rob Lowe, isn't that Rob Lowe? Literal equations are literally my favorite type of equations. He's a pretty good actor. Okay, so let's get rid of the fraction. I always get rid of fractions. So I'm going to multiply by 3j to both sides. So on the left, I'm left with 8h equals 18jk. But I'm solving for j, so I need to get rid of that 18 and the k. So I'm going to divide by 18k. And I'm left with 4h over 9k. I just reduced that equals j. This one, solve for b1. So first thing I'm going to do, so we have that half there. I want to get rid of it, so I multiply that by the denominator. So I multiply by 2. So I have 2a equals h times b1 plus b2. Let's get rid of the h, so I'm going to divide by h. So I have 2a over h equals b1 plus b2. Solving for b1, so I'm going to subtract the b2. So I have 2a over h minus b2 equals b1. This one, solve for y, so I'm going to subtract that 3x over. So I have 4y squared equals 7z minus 3x. Divide by 4, so we get y squared equals 7z minus 3x over 4. To get rid of that squared, you square root it, so you get y equals the square root of 7z minus 3x over 4. Okay, solve this one for m. Notice we have two m's here, so let's get all of the m's to one side. Anything that doesn't have an m goes to the other side. So I'm going to have mn minus 2m equals p. So greatest common factor, see how we can factor out that m? So let's factor out the m, and that's going to be n minus 2, and then we can divide by the n minus 2. So m equals p over n minus 2. Cool? Okay, absolute value equation. So absolute value, if we think about absolute value, it's the distance away from 0. It's the absolute distance away from 0. So that's why if we do like -6, the absolute value of -6 is 6, because that's the distance away from 0. Same thing with like, I don't know, -1,949. The absolute value of that is 1,949 because it's the distance from 0. Okay, I'm sad. Then turn it into something positive. The absolute value of I'm sad. Positive. Modern problems require modern solutions. Okay, so to solve these equations, it's the distance away from 0, and we always have two answers to these. So to do that, we're going to set it equal to the positive, and we're going to set it equal to the negative. Okay, so we have -2 minus 10w equals 98, and then -2 minus 10w equals -98. Then we're just solving these equations. So I add the 2, I get -10w equals 100. Divide by -10, I get -10. Here, add the 2, I get -96. Divide by -10, I get 96 over 10, which is 48 over 5, which is 9.6. Plug them back in, make sure they work, and they both do. In your calculator, if you have like the TI-84, if you do math and then go over to number and then it's ABS, I'll write that down real quick. So in the calculator, if you click math, it's under, so it goes like second, alpha, and then math. This is the one you want to click. And then you go over to the right, so click that right arrow, then it will say ABS. And that will bring up the absolute value for you. Okay. Let's do this one. So first thing you have to do is isolate that absolute value. So I'm going to subtract the 1. So I get -10 times 9r plus 3 equals -30. Divide by -10. So you get 9r plus 3 equals 3. Now we have two of them. So 9r plus 3 equals 3. And 9r plus 3 equals -3. Subtract that 3 and you get 0. So r equals 0. Subtract the 3, you get -6. Divide by 9 and you get -2/3. Plug them in, they both work. This one, so I'm going to add that 5 over. So notice here we have two terms on the right side. We're still going to do this the same way, break it up into 2. So the positive is just the same. So 6n minus 7 equals 3n plus 5. On the right side, it's going to be the negative of the whole right side. So -3n plus 5. This one we can solve, so subtract the 3, we get 3n, add the 7, you get 12, divide by 3, and you get n equals 4. For this side, I'm going to distribute that negative in, so you get -3n minus 5. And I'm going to add that over, you get 9n, add the 7, you get 2, divide by 9, and you get n equals 2/9. And they both work. You get 2 for the price of 1. Okay, solving quadratic equations. We've done a bunch of factoring, and that's what I am going to do. What if I told you you could use factoring to solve quadratic equations? So if we factor this, y squared minus 13y minus 30 equals 0. That factors to y minus 10, y minus 3. Set those both equal to 0, so you end up getting y equals 10 and y equals 3. Pretty straightforward. Do this one. That is the difference of squares. So if we factor that, that's the same as 4d minus 9 and 4d plus 9. Set them both equal to 0. Solve that, so you get 4d equals 9, so d equals 9/4. Subtract that, 4d equals negative 9. Divide by 4, d equals negative 9/4. This one, we're going to factor using GCF, so let's get everything to one side. We always need this set equal to 0. I should probably write that. Always set equal to 0. Set equal to 0. Sometimes I think my handwriting's really good, but then other times it just like jumbles together and I think it gets hard to read. So if it's ever really hard for you guys to read, just send me a message. Be like, yo, your handwriting sucks. Like, can you fix it? And I'll try my best. Don't say sucks. Like, that's mean. Say, like, you could use some improvement. Okay, here, so we can factor out a 2w. So 2w and 2w plus 5 equals 0. Set them both equal, so w equals 0 and w equals negative 5/2. Okay, this one, so see here we only have an x squared. Well, if you only have a squared term, you can use square rooting. Okay, so I'm going to subtract the 11 and I get 3/2 x squared equals 48. Multiply both sides by 2, so we have 3x squared equals 96. Divide by 3 and I get x squared equals 32. Then I can square root both sides, so I get x equals plus or minus the square root of 32. And if you break down that square root of 32, it's the same as 4 square roots of 2. Neat. Okay, last one. So let's get everything to one side. So I get k squared plus 10k plus 8 equals 0. I always want this first term to be positive. Okay, we always want it to be positive. When it's negative, it makes it a little bit harder. So if this is positive, now if we try to factor that, we cannot factor that. So we have to use the quadratic formula. Okay, and I know you've seen this last year, but it's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And there's lots of ways to remember it. You can remember it like to the pop goes the weasel, however you need to do, but you should know that formula. It's a good one to know. So if we do this, a equals 1, b equals 10, c equals 8. So then this is going to be k, because our variable is k, equals negative 10 plus or minus 10 squared minus 4 times 1 times 8 over 2 times 1. So that's negative 10 plus or minus square root of 10 minus 32 over 2. Well, 10 minus 32 is 68. So negative 10 plus or minus the square root of 68 over 2. If we break down the square root of 68, that's the same as 2 square roots of 17. So this is negative 10 plus or minus 2 square roots of 17 over 2. Then 2 divides into all of that, so that's the same as negative 5 plus or minus the square root of 17. Okay, the biggest thing to recognize here, well, there's a lot, but is that there are two answers. So the first one is negative 5 plus the square root of 17, and the second one is negative 5 minus the square root of 17. Okay? And I think we're done here. Bye.